First we are going to do how to get z test. So for z test value, what we do is we need to know what is graph. Like this is the normal distribution graph. Okay, so here in between this is median mostly. Okay, sorry, median, mean, mode, everything lies in this. So if a question is given, then write the mean in the center. Now I will talk in basic. So this is considered as 0. Okay, 0, or rather than you just make a sign of mu. Okay, now it is told that this much is 0.5 and this much area is 0.5, which means the total area covered by this graph is 1. Okay, in z test there is two types of possibility, which is one tail or two tail. Now what do we mean by one tail? In one tail there is one rejection region. Okay, and in two tail there will be two rejection region. So in order to find out how this rejection region is, we should know that what is the way we are calculating that rejection region. So whenever a researcher do a research, so he need to have confidence on his research. Like, yes, I'm confident that this research is this much amount of true. So this will give you some percentage, 90%, 95%, or he will say I'm 99% sure that my research is good enough. Then comes like if he is 90% confidence, then 10% he is not, or 5% he is not, or 1% he is not, which means the data at this 10%, 5% or 1% can be considered as maybe fault. Okay, so this is called significance level. So now we got what is significance levels. Like in total it will make 100%. Okay, like 90% he is sure, then 100% is the significance level. So for one tail we will write significance level like 10%, 5%, 1% as it is. Okay, but in two tail what we do is it is divided in two parts. Okay, one part is on the left side and another part is on the right side. So we will see the graph mostly for two tails. It's like this is the graph he made. Here is one significance level, here is another significance level, and this shaded area will have the half of the significance level, like 5% one side and 5% on another side, 2.5 in one side and 2.5 in another side, or 1% 0.05% in one side and 0.05% in another side. So equally divided is in the two-tail test. Okay, so I hope this much is clear. In class, ma'am will ask find the z value. Okay, so z test we do for finding the z. Z test is the test, but in that z test we need to have a z calculated value, and one more we have to z observed value, or like the mod z, which is the table value. Okay, so this table value we need to learn to calculate first before we solve the problem. So first we make this graph, and now our question is given that significance level is 90%. Okay, confidence level is 90%. So what is the significance level here? Then the significance level will be 10%. Okay, I will take both the thing. One is I will take one tail, another is two tail. So first we are taking one tail. So in one tail the significance level is 10%. So either it can be the right side or the left side. Now whenever we are considering that hypothesis is greater than in hypothesis we are considering mu1 is greater than mu2. This arrow mark is pointing towards right. So our one tail will be that on the right side. Okay, if we are considering that h1 is less than h2, okay, like in alternative hypothesis mostly, because in h0 we are considering that both are equal. It depends on the question also, okay. If it is this side, then shadow part will be on the right, okay. So in such cases, in one tail cases, we will write like our rejection region will be 10% in any of the one side, okay. So now this whole area is 100, okay, 100%. So 10% on the right will be represent like this. So this area will be 50% in total, because it is dividing into half. So 50% this side, 50% this side. So if this area is 10%, so this area will be 50 minus 10, that is 40%. Okay, this is in term of percentage, but you have to write in term of decimal. Okay, so we will again make a graph and we will put a line. This will be 10%. So 10% can be written as 0.1. So here it will be 0.1. Okay, this is the rejection region. This data can be rejected only from the right side, one tail test, or from the left side, one tail test. Okay, this will be 0.4. This total will be 0.5, and this total will be 1, complete whole table. Okay, so we are getting here 0.4. So we will go to the chart which is given in our book. Okay, I will put the chart photo here. Okay, then we can see where this 0.4 is coming. So wherever this 0.4 is coming, we need to check. Okay, so I'm just drawing here for rough, later on you can see. So this is like the Z test table is given. So if some 0.4000 is given, I don't know, I just giving example, or 0.4005, so which one you will take? This one you will take, because it is the exact same. Okay, so we will add this amount and this amount, which it will be in something 1.x y 0.0 y. Okay, so it will become 1.xy like that. Okay, we will see. And after this we will write that z value is whatever we are getting from the table. Okay, so z value is this location, no, it is here z value. In one tail test only one sided. If it is on the right side, the z value is positive, whatever the amount came. If it is on the left side, then z value will be negative, whatever the amount comes. Okay, now we will just check the table. Here we are getting that z value will be. So when we saw the chart for 0.4000, we are seeing that 1.2 at 1.2 and at 0.08 and 0.03 we are getting these kind of value. We are not getting exactly the value which we want, but 0.0003 lesser or 0.0015 greater than that. So we can consider any one of them, and we can take z equal to 1.2 plus 0.08, which is nothing but 1.28. Directly you can write like 1.28. 8 is there, no? 1.28, 1.29, any one you can consider. So here we will write 1.28. Okay, for another side, like the left tail, we are making this one z equal to minus 1.28, because it is on the left side. So whenever we make a number scale, it is 0, minus 1, minus 2. It's like that, right? 1, 2. So this is how we are getting it. So this area covers 0.1, 0.4 and this 0.5. Okay, total it will be 1. Now for two tail, like I'm taking the same confidence level is 10%. Okay, when the confidence level is 10%, then I'm making this graph, making one line, putting here as mu, okay, or 0, whatever you want to consider for this moment. Okay, for calculating the z value, just both the side I will draw because it's a two-tail test, and for two tails we will take h1 is not equal to h2. In one tail we are taking greater than or smaller than, but here we are taking not equal to. When it is not equal to, the significance level is, this is 90%, sorry, 10%, right? It will be equally divided both the side, that is 5% and 5%, which will be written as 0.05, 0.05. This 5%, which is 5 divided by 100, which is 0.05, and another also 0.05. So this side it is 0.05 and this side it is 0.05. 0.5 minus 0.05 equal to 0.45. Okay, easy. 45 plus 5 equal to 50. Okay, so here we need to check this one in the graph. So when we go to the graph, we will see this. This is 4505. We want 4500, and here it is 4495. So any one you can consider. It is just 0.0005 more or greater than the expected value. So here we will get z equal to 1.6 plus 0.04, which is 1.64. Okay, I hope that is clear for one tail and two tail test.